Okay, here's a couple of good questions. First one, how many distinguishable ways, so permutation, can the letters of the word window be arranged? So there's 1, 2, 3, 4, 5, 6 letters. So I could say to arrange those 6 letters, I could say it's 6 permutations of 6, or you could just say 6 factorial. I guess, or you could go like this, 4, 5, 6, and say there's 6 things I could put in there, and then 5 times 4 times 3 times 2 times 1. Now, where I have to change that a little bit is because there's 2 W's. So if you have letters that repeat, then I have to divide these answers by how many times they repeat. So there's 2 W's, and so I would divide this by 2 factorial. Okay, because you could rearrange, this W could be there and that one there, or they could swap places. So you divide it by 2 factorial. Okay, this next question says rider's height is by this function. What is the rider's height at a time of 20 seconds? So all I could do is just plug in a 20 wherever I see a T there. Then use the graph to answer these questions. Okay, well, let's just fire up Desmos and see what we've got here. Desmos, beauty. So let's type in the function. So y, come on, y equals -8 sine bracket pi over 6 bracket x, we'll call it x, plus 9 over pi, go over a couple, plus 9. There we go. Okay. There. Okay, so there's our function. And now for one of the questions, just to test it, you could see, look to see where t is 20. It's over here somewhere. 20, right there. So I can't get my finger exactly on it, but it's about 13.445. One way you could find exactly that number is you could graph y is equal to 20. No, x equals 20. X equals 20 there, and tap on that line. So at 20 seconds, the Ferris wheel is 13.48 meters above ground. Or you could do this. You could go -8 sine bracket pi over 6 bracket. Instead of t, I'm putting a 20 there, plus 9 divided pi bracket plus 9. And they should come up to about the same thing. 13.48 here, 13.48. Okay, then they said use the graph to answer some other questions. Let me see what their questions are here. So at what time will the rider reach the maximum height? So if I look at the graph, the maximum height is right up there. So the maximum height is 17. Well, that's the next question. And that happens at 6.135 seconds. So right there, or at 18.135 seconds, etc. How long does it take to go around once? Okay, so I'm starting here right at the bottom. I think that's close to the bottom. And that's 0 seconds. And then here, it looks to be about 12 seconds is how long it takes them to go around once. You could do the period. Could you do the period? So that's what the definition of a period is to how long until it starts repeating each other. So you could go, the period is 2 pi, let me write it down. I wonder if this will come out right. So 2 pi over b. And in this case, our b value is this one. So 2 pi over 6, or 2 pi divide pi over 6, or 2 pi times 6 over pi. The pi's cancel, and 2 times 6 comes out to 12. Yeah, so the period would be exactly 12. You could look at it on the graph too. So on the graph, come on. There's a dot there. So there at 6.135, it's at 17, and then it's at 17 again at 18.135. So 18.135 minus 6.135 is 12. So that would be the period of the graph, or how long it takes to go around once. Make sure your calculators and radians. Well, I guess I answered all the questions then. Okay, maybe just one other thing with that graph. So I graphed that x equals 20 to help me determine the time would be 20. Another question you could have asked with that one would be something like, at what time is the height maybe 16 meters? And so you can graph y equals 16, and that puts a line across, and again, you can go in and tap at any one of those points, and that'll determine the time when the height of the Ferris wheel is at 16. So at 5 seconds, 7.1, 17.17, 19.1, at each of those times, that's when the graph will hit 16 meters up. All right, hopefully that helps you with those two questions.